Hello everyone. Today, we will discuss the content of Chapter 1, which focuses on the evolution of blockchain technology. First, let's take a look at the development history of blockchain. The technological origins of blockchain lie in electronic money, cryptography, P2P networks, distributed databases, and other areas. It has gone through three main versions. Blockchain 1.0, also known as Bitcoin, introduced technologies such as programmable money, protocols, digital wallets, and scripts. In Blockchain 2.0, the primary technological feature is smart contracts, which involve virtual machines, dApps, and more. Currently, the mainstream version is Blockchain 3.0, which focuses on technologies related to digital identity, digital social networks, and digital government. In Blockchain 1.0, we can see it is divided into 5 layers. From bottom to top, they are data layer, network layer, consensus layer, incentive layer, and application layer. The data layer primarily involves 6 key technologies: block data, chain structure, digital signatures, hash functions, Merkle trees, and asymmetric encryption. Most of these fall under the category of cryptography. The network layer involves P2P networks, and the consensus layer uses POW. In Blockchain 2.0, the smart contract version, it also has 5 layers. However, the main difference from version 1.0 lies in the consensus layer and the application layer. In Blockchain 2.0, the application layer is referred to as the smart contract layer, which mainly involves virtual machines and script codes. In the consensus layer, besides using POW and POS, version 2.0 also employs protocols such as DPoS and PBFT. Blockchain 3.0 is the current mainstream version under development. It focuses on the following areas. 1. Key data on-chain. In previous versions, all data would be put on the blockchain, leading to blockchain bloat. In version 3.0, the focus is on putting only the key data on the chain. 2. Multi-chain collaboration. Version 3.0 aims to enable multi-chain collaboration, where multiple blockchains can work together and integrate. For a single blockchain, it acts as an information silo. However, in the current development stage, such as in government departments and businesses that need to share multiple types of data, it becomes necessary to consider the integration of cross-chain information interconnection. 3. Evolution to DLT. The blockchain structure is evolving toward a distributed ledger technology, DLT. Next, let's introduce the reference architecture of blockchain and mainstream platforms. The blockchain reference architecture primarily consists of a 6-layer model. From bottom to top, we can identify the 6 layers: data layer, network layer, consensus layer, incentive layer, contract layer, and application layer. The data layer at the bottom is primarily concerned with data security. It utilizes cryptographic technologies such as hash functions, Merkle trees, timestamps, and asymmetric encryption. The network layer ensures distributed autonomy, which is why it employs a point-to-point network. The consensus layer enables distributed trust and crowdsourcing collaboration, so consensus algorithms like POW and POS are primarily used. The incentive layer focuses on providing effective economic incentives, and it mainly relies on issuance and distribution mechanisms. The contract layer represents smart contracts. It involves script codes, algorithm mechanisms, and the implementation of smart contracts. The application layer is designed for human-machine interaction, focusing on the user interface. Let's analyze the essence of these 6 layers by comparing them to the construction of a car. The data layer is like the basic hardware infrastructure of a car, consisting of essential components that the car cannot function without. The network layer acts like the fuel or electric system, which transmits energy or information to power the car. The consensus layer is akin to the engine, which is one of the core components of the car. The incentive layer is like the lubrication system in a car, as the smooth running of a car greatly depends on the efficiency of its lubrication. Similarly, the incentive layer plays a crucial role in motivating the blockchain to function effectively. The contract layer implements high-level automation features, similar to the automatic transmission in a car that performs automated operations. The application layer refers to the use case of the car, including scenarios such as off-roading, highway driving, high-speed performance, and more. From a disciplinary perspective, we can analyze these layers further. Blockchain is a sub-discipline under computer science. It also intersects with control and automation. It mainly involves knowledge from multiple interdisciplinary fields, such as cryptography, management, economics, and law. The United States blockchain reference architecture is also divided into 6 layers. The International Organization for Standardization Technical Committee on Blockchain and Distributed Ledger Technologies ISO TC 307 was established in September 2016. It held its first working meeting in 2017, forming 7 working groups and research groups. From a business perspective, the blockchain reference architecture submitted by the United States is described as an exchange network that facilitates the transfer of value, assets, or physical entities between mutually recognized participants. From a legal perspective, transactions within the blockchain ledger must be verified, non-repudiable, and tamper-resistant. Furthermore, blockchain does not require intermediaries or third-party participation. From a technical perspective, blockchain is a distributed ledger that references other data storage systems for ledger data and globally replicates it. In summary, the blockchain reference architecture aims to support blockchain interoperability, enabling trustworthy data exchange between users, distributed applications, and blockchain networks. Next, let's study China's blockchain reference architecture, which was established in 2017 by China Electronic Standardization Institute of MIT. It is divided into 2 views, the user view and the functional view. In the user view, it primarily involves blockchain service stakeholders, blockchain service clients, and blockchain service providers. These 3 groups form a close cooperation network. Let's now focus on the blockchain reference architectures for different platforms. We will compare Bitcoin, Ethereum, and Hyperledger Fabric as examples. At the application layer, Bitcoin primarily focuses on Bitcoin transactions. Ethereum is designed for Ethereum transactions, while Hyperledger Fabric is geared towards enterprise blockchain applications. In terms of programming languages, Bitcoin mainly uses Script. Ethereum primarily uses Solidity. Hyperledger Fabric mainly uses Go and Java languages, making it more friendly in terms of programming language implementation. Regarding data structures, all 3 are fundamentally similar, being based on Merkle trees and blockchain. At the consensus layer, there are some differences. Bitcoin primarily uses POW. In addition to POW, Ethereum also supports POS. Hyperledger Fabric primarily uses PBFD and SBFD algorithms. At the network layer, all 3 platforms generally use point-to-point P2P networks. Now, let's look at Tencent's blockchain reference architecture. It is divided into user management, basic services, smart contracts, and operational monitoring. These four components help enable the computation of intangible assets such as digital tickets and digital gold. JD.com's blockchain reference architecture primarily aims to achieve product traceability, including service platforms, component models, and blockchain protocols. Lastly, let's analyze the differences among these three mainstream platforms. Bitcoin mainly uses the POW algorithm. It does not support smart contracts and primarily uses C++ as its development language. Ethereum involves consensus algorithms like POW and POS. It supports smart contracts and mainly uses Go as its development language. Fabric mainly uses the PBFT consensus algorithm. It also supports smart contracts and primarily uses Go as its development language. In terms of TPS and throughput, Hyperledger Fabric has the highest throughput, while Bitcoin has the lowest. That concludes the content for this lesson. Thank you, everyone.